Now, the structural health monitoring system what we discussed also has an additional advantage, which is the alert monitoring system. If you look at the figure here, this is actually the layout of SHM design 2, which we are discussing for the lab scale. The typical sensor node what we have here is a combination of sensing unit, processing unit and communication channel. So, it contains all. Okay. Now, interestingly, when the system is ideal, when the structural system is ideal, sensors are designed to remain in sleep mode. Even under a small displacement of the structure, sensors will become active and start acquisition. Now, the locations of sensors are very important in the design. The locations are chosen as per the preliminary numerical analysis done. In the present study, we have sensor nodes and base station connected to a single network. So, there is no master slave configuration. Because in the lab scale the sensor nodes are very small in number, therefore, there is no need to have an expandability of master slave configuration. So, the sensor nodes and the base station are connected to a single network. Okay. Now, if you look at this figure which is talking about the layout, there is an additional system what we have generated in this, which is the alert monitoring system. So, you monitor the system, communicate to the server, then get the report on the client server. This is a standard system what we have for SHM, which can be applicable to a real time monitoring also. Now, more interestingly, when you have a preliminary data of analysis of the offshore structure and you know what is the maximum displacement the structure is permitted to undergo, you fix up what we call as a threshold value. Okay. When the acquired data on mapping with the existing data exceeds the threshold value, then it has to trigger an email, it has to also trigger an SMS, and the email has got to be received in the client server showing that the data or the structure has undergone a displacement or a response which is above or more than the threshold value. So, the comparison of the acquired response with the threshold value is then communicated to the base station to indicate at what time, at what time frame, at what sensor, at what location on the structure this exceedance happened. So, there is a physical mapping of the exceeded data with that of the threshold value onto the real time structure, so that the client server person looking at the report will know at what location of the sensor, on the other hand at what location in the structure the exceedance of the value has happened and at what time frame this has happened. Now, there is a common possibility that you can always ignore these statements by oversight. Therefore, there are dual mode of alert monitoring happening in this design. One is by a SMS alert which tells you what has happened, and also by a standard email format which is a legal document stating that the sensor has communicated to the client that at a particular location at a particular time framework the threshold value of the structure has been exceeded. Whether it is exceeding and continue to exceed is a different issue, it gives me a trigger once when it is exceeded. Okay? So, that is what we are adding now to the alert monitoring system to my SHM. Let us discuss about this now. So, we are now entering into a design of alert monitoring system, which is the part of the SHM in case of design 2. The alert monitoring systems has many advantages. It actually generates a reliable report when the acquired data exceeds the preset threshold value. That is first one. Second, this communication of alert instantaneously, that is very important. Now, how do you identify the threshold values? The threshold values are identified by benchmarking the average of previous records in non-critical condition for the same structure. So, you keep on acquiring the data in a non-critical stage, the average of the previous records will be considered as a threshold value. Now, exceedance of threshold value is an indicator of damage. So, now the question is, damage location is known because the sensor location is known, damage exceedance is quantified because it has exceeded the threshold value. Therefore, one can take appropriate action for repairing or reconstructing the structure. Okay. So, on exceedance of the threshold value, the processing unit will trigger an email alert and subsequently also transmits the data to the base station. Now, server in the base station will process this data and performs detailed analysis. Subsequently, an alert message will also be displayed in the user interface. Now, there are many advantages of this. The alert message displayed on the monitor of the user reduces the workload on the administrator Okay. Further, SMS triggered on the registered mobile number is an authenticated information. Okay. It is an authenticated record of information which cannot be tampered. Okay. Now, the sensors used in SHM2 design are also to be calibrated for the lab environment, because the real time monitoring and the wrap time monitoring will be different. So, we have used the wired accelerometer, which is MPU 6050 chip in the present study. The calibration in the present test, in the present experiment was done using a shake table experiment. I am not showing the results of the shake table experiments here. So, now we have two systems, which is wired and wireless, both are for structural health monitoring. Let us compare them and see how was the result. Wired sensors had 393P04 PCB module and Spider 8 data acquisition system, whereas wireless system had PIC microcontroller and ADX L335 802.15.4 protocol for system 1. This is system 1, and system 2 had Raspberry Pi board with MPU 6050 802.11x protocol for system 2. Okay, this we have explained. Sensors are physically connected in this case, whereas in this case sensors are not physically connected, but they work as an independent module. The installation is complex because lot of wiring is required. It is very easy and quicker to set up. The DAQ will collect data from the sensor unit, whereas in this case the central server will collect the data from the sensor nodes through 804.15.4 protocol, whereas in this case 802.11x protocol, and it makes it visible to the public domain as and when required. So, the data acquired is available for checking, whereas in this case the data acquired is not known. Okay. The central server should be connected through wires, that is the catch here, whereas no wired connection is required. The central server should be placed closely because we have a distance restriction to the acquisition node, whereas in this case the central server can be placed anywhere because we are having a different protocol for wireless communication system, because the database will be uploaded directly to the web server in system 2. The data loss is lesser because there is a direct connection between the sensor and the DAQ. There is a high probability of data loss in wireless sensor networking. However, in system 2 this is greatly reduced by having a local database on the system itself. In wired sensor, the greatest advantage is there is no noise interference, whereas in wireless sensors signal to noise ratio seems to be very high because we generated white noise in case of system 1 design as I showed you earlier, but in system 2 design the noise interference is comparatively lesser. So, now this table shows very clearly the comparison between 3 systems: wired system, wireless, that is SHM design 1 and design 2, out of which one can see here the wireless system design 2, which has been recommended for experimentally investigating BLSRP under wave loads and the lab scale, has been very successful. So, there are some challenges when you do this. Let us quickly see them. What were the challenges in this system design which we encountered, which we can share with the benefits of the viewers? Even though this SHM system 1 and system 2 are successful in lab scale, few factors are necessary to be considered when you do a real time monitoring. Okay. The first issue is, in real time monitoring, the frequency range of the structures can be different. Therefore, sensors should be chosen based on the operational frequency band of the structure. That is the first issue we have. The second could be the layout of the sensors. The sensor network in lab scale, that is the interface between hardware, is unaltered. Whereas, in real time monitoring, the bandwidth and latency issues should be covered up. Okay. Now, when you go for long term monitoring, sensor should be embedded in the structure. So, therefore, here the main challenge comes is human intervention and harsh environment. Further, the IEEE protocol 802.11, which is used in the lab scale, is not compatible with all kinds of ocean environment. So, there are alternatives. Alternatives could be voice over IP, broadband data, and video communication services. So, friends, in this lecture we discussed about the design of structural health monitoring on a lab scale applied onto a new generation platform and showed you each element of the SHM design, compared them with the wired design and show them the advantageous features or different elements: sensing unit, data acquisition, processing unit, communication channels, and alert monitoring systems. In the next lecture, we will also talk about the structural health monitoring applied on purely within alert monitoring by creating a post-related failure on a lab scale on an offshore platform again, and see how the post-related failure can be captured using the SHM design 2 on a lab scale. Thank you very much. See you in the next lecture. Till then, bye.